Now, Python data types. Python is known for its dynamic typing, which means that the data type of a variable is determined at runtime. Python supports various data types, allowing you to work with a wide range of data. Here are some common data types in Python. Before I go on, let me just quickly use another explanation again to show you this data type that we want to look at. What do you mean by dynamic and what is static? Let's take, for example, in your house, you have your ceiling fan, the ceiling fan, and then you have the control of the ceiling fan. You know, that control, you are tuning it analog, in analog form. One, speed 2, speed 3, speed 4, speed 5. Now, on one side of it has 1, 2, 3, 4, 5. On this other side is connected straight to the ceiling fan. So you are using the analog tuner to tune to 1 at runtime, 2, changing the speed, 3, changing the speed. Now, this side is assumed to be the variable. So I'm having a variable at this side, which is A, and that A is connected to the what? To the ceiling fan. Now, for every time I tune to the next speed, this variable is stable, right? Dynamically moving and changing the speed. That is what you call dynamic. You are moving it at runtime. So at the time in which the operation is taking place, that is when I'm changing the data. So I'm changing it. So I'm pointing this variable at this side to speed 1, speed 2, speed 3, speed 4, like that. That is for your ceiling fan. Now for static, you look at a remote, your television remote control. This is your remote control. Now, on this remote control, you have 1, 2, 3, 4, 5. You can pre-program different channels on this. So I have channel, maybe channels television on 1, Silverboard on 2, TVC on 3, Wazobia TV on 4, like that. I can have them like that. Now, I have pre-assigned those TV stations to these various numbers. So anytime I take this remote, I just press 1. I already know which channel is inside 1. So I'm not expecting to press 1. I'm not going to press 1 and expect another channel because I've already predefined the channels inside. That's static. So if I want this one to carry a different channel, I have to come back again and reprogram it. So that is the difference between C language and Python. In C language, you will predefine the data type at the point of declaration. So you say int A. But in C, it is at runtime I can assign any data to the data type, to the variable. And then my Python interpreter will automatically know which class it belongs, then check the functions that have, the operation that I want to carry out, and then check the class of that object to know if that method is inside, and then carry it out for me by calling the processor to go to the memory and pull the data and carry out this program. That is how they are linked. This is the concept. And I need you to understand this concept. So let's go back and continue our reading. Now, numeric type, int. This is the type, int. Integer data type for whole numbers, e.g. 5 minus 12, 0. Float, floating point data type for decimal numbers, e.g. 3.14 minus 0.5. That is float data type. String data type, str. A sequence of characters enclosed in single, double, or triple quote. Example, hello Python. Then you have 1, 2, 3, 4, 5. You can see this is not number. This one is not numeric because of this single quote that you are seeing. This automatically makes this what? A string. So if you supply this, you cannot carry calculation on it. That you have to understand. Multiple line string, you can see triple quote. So once you put any data inside a quote, either single quote, double quote, or triple quote, that automatically becomes a string. Boolean represent the truth values, which is what? True and false. That's only two types, which is true and false. List, and other collection of items that can be of different data types. Lists are defined using square bracket, e.g. See this with So with this square bracket, you see 1, 2, apple. So this list is containing numeric data type. It's also containing a string data type. But how do you know that it's a list? It's using what? This square bracket. Now, tuple. Tuple is similar to list, but immutable, meaning their element cannot be changed after creation. Tuples are defined using parentheses, e.g. So you're having, so I can, if I'm going to change this 1, 2, apple to, inside this level, I want to change it to tuple. All I just need to do is remove this square bracket and change it to what? To what? To normal bracket. 1, 2, banana. This is what? Tuple. And it is what? Immutable. I'm going to explain the meaning of that to you as we go on practically. Then you have set. An unordered collection of unique elements. Set are defined using curly braces, e.g. This is an example of set. Dictionary, a collection of key value pairs. Dictionaries are defined using curly braces and colons, e.g. name, colon, John. So this is the key and this is the value. H, colon, 30. So this is the key and this is the value. So that's what it's telling you. Define using curly braces. Key values pairs. So this is a pair, name and John. So name is the key, John is the value. H is the key, 30 is the value. So then you have non-type, represent the absence of a value or a null value in Python. Complex. Complex represent complex numbers in the form of a plus bj, where a and b are real numbers and j is the imaginary unit, which is actually the square root of -1. Byte and byte array used to represent binary data, where byte is immutable and byte array is mutable. We are still going to understand the concept of the immutable and immutable, meaning you can change the data that is already assigned or you cannot change. Range. Range represents a sequence of numbers used in loops and iterators. Custom classes. Python allows you to create custom classes to define your own data types. Now, these are the various data types that we have in Python. Not all, but at least the ones we are going to practically use. And once you understand this concept, you can always apply it to the other ones. Now we've come to our PyCharm. So I am going to show you with one of our programs. So this first program.py that we created, there's nothing inside. I'm going to use it. So I'm just going to open this and then we'll type whatever it is that we want to do here. So we are going to look at the first one, which is what? Numeric. So I'm just going to just type numeric data type. Right? This is what we are going to look at, numeric data type. And in that, so the one we are going to look at now is numeric. We are going to look at this numeric. And under this numeric, we have integer, we have float, we have complex. Even this Boolean sometimes can be classified under this numeric. So, but for this design, I have the integer, the float, and the complex. And I'm just going to show you practically these three. I'm going to declare variables and supply this data to it, supply this data to another variable, and supply this data to another variable. And I'm going to print it out on my screen. So I'm just going to put this in comments so that it will not throw us error. So I'm just putting that in comment. Now I'm going to come here, numeric data type. So I will declare a variable, say test. I'm giving a variable name test. And this test, I'm going to assign a value to it. And let's say value 5. Now, the moment I assign 5 to test, the Python interpreter knows that this test is what? Integer data type. But how will it know? There is a function in Python that we are going to call now that will tell us which data type this test is based on this value that we have supplied. So then I'm going to supply another one. I'll say test 1 and I'll say 3.14, right? And I'll supply another one, test 2, and I will say true. I'm actually now bringing in the Boolean. I told you that sometimes can be classified under the numeric data type. So I'm going to say test 3, and I'm going to say 10 plus 5j. So what data type are all these? We are going to find out. what data type is this, what data type is this, what data type is this, what data type is this. Now, test is pointing at this data type, is this data. Test 1 is pointing at this, test 2 is pointing at this, and test 3 is pointing at this. Now, in Python, there is a function called type function, which is this type. This function, this is the function you are going to call in order to know which class this variable will belong. So based on this data, I can now tell which class this variable belongs, and then I will now be able to check inside that variable to see all the methods that are there. And that will help me to know what kind of operation I can carry out on this particular type of data that I've supplied. So I'm going to use this test function to find out the data types of each of these, and I'm going to display it on the screen. So I'm going to say test 5. For this one, test. Then I'll call the type function again, and I'll supply test 1 to it. I'll call the type function again, and I'm going to supply test 2 to it. I'll call the type function again, and I'm going to supply test 3 to it. Now, when I do this and I execute, it's just going to find out the class, but I'm not going to see it on the screen. So what do? I am going to supply this now to my print function because I want it to show me on the screen the type of data type. Assuming I was using I'm using the script mode, so I will have to call the print function to do that. If I was using the interactive mode, there is no need. I will have just pressed enter and to display all this for me. So I'm going to call my print function, and then I'm going to put this inside the print function. So I'm going to call the print function here again, and then I'm going to supply the output of this test to it. Then I will come back here again and call another print function and supply the output of this text to it. Then I will come back down here again and call the print function and then supply the output of the type function to it. So this is it. So now I want to know what class does this test variable belongs based on this data. Because I've supplied this data to test, automatically it assigns a class to it. This test becomes an object of the class. This test 1 becomes an object of that class. This test 2 becomes an object of that class. This test 3 becomes an object of that class. So I want to know which class each of them belong. So I have called the type function and I've supplied this variable to it. And then I've also supplied this output to what? To my print function to display on the screen. So I'm just going to run it. So this is it. Now, you can see that the first one is int, the second one is float, and the third one is bool, and the fourth one is what? Complex. Now, I can equally change this and say the data, I can change this and say, you see, now I'm beginning to use all those things that I've taught you, the print function, the type function, the variable. I'm beginning to put them together now to bring out an expected output. So I can say print, then I'll supply a string. So I'll put a string here and say the data type for the variable test is, then I'll put this one here. I can type it like this. I can type it like this, and I'll put this as comma. and then I'll put this as comma. Then I'll put this as comma. So I'm supplying how many parameters to my print function? 1, 2, 3, 4. I'm supplying 4 parameters to this print function. Then I'm going to execute it. You see? So I have the data type for the variable 5 is class. So I'm calling this test. I'm just going to copy this and then I'll paste it here. So this one will be test 1. Then I'll paste it here. This one will be test 2. Then I'll paste this here. And this one will be test 3. So the data type for the variable test is this. So this is a parameter. This is a string literal that I'm supplying to this my print function. So I'm telling the print function, print out this thing, this statement exactly as it is. And then go to this test variable and bring out the data that is inside. Right? Bring out the data that is inside. Now, if I don't want to do that, assuming if I want it to tell me this as a variable, so I can equally still put this inside here as a string, and then put this here, and put this here. Now, so if I want it to come out in my message, I'll just put this here, like this. I'll do this. This is what I want. Okay, so I've actually changed my script. So this one is type yes. Okay, so this is it. This is my script. This is what I want. So I want you to print the data type for this variable test is then to tell me the data type. The data type for the variable test1 is it to tell me the data type. In this case now, I'm supplying only 2 parameters to my print function. So I'm just going to execute this. And to tell me that the data type for the variable test is class int. The data type for the variable test1 is class float. Data type for the variable test2 is class bool. The data type for the variable test3 is class complex. So because of the values that I've supplied to each of these variables, the Python interpreter automatically knows which data type. Now, if I'm now going to carry out a calculation, I can now say, I can come here and say, and declare another variable and say A, or I say result equals test multiply by test 1. Now, I can now come here and say print result. Look at, you see, test 1 is what? 5. Test is what? 5. Test 1 is what? 3.14. Now, I am now carrying out a calculation, which is what? test times test 1. The Python interpreter will look at this and know that this is numeric data type. And in numeric data type, which is what? The integer and the float, there is a behavior in it that allows us to do this calculation. It will carry it out, and then it will give me an output. Now, but if I say, okay, yes, if I leave it like this, no problem, it will still work. But assuming this data type is a string, which I'm going to come to, and I try to carry out this, you will see what the output will be. So I can carry out this. Now, the data type immediately, through the data type, my Python interpreter knows which class it belongs. And then it will go into that class and see if there is a method that it can call that will be able to carry out this calculation. Once that is available, you can now tell it will now save this in memory, and then tell the processor to go to the memory location, pick what is inside this test, test 1, carry out this calculation on it, and store the answer back in this memory location. Then it will now print out this result on the screen for us to see. That's exactly what happens. So this is what I have to show you concerning numeric data type. I'll stop here, and then in the next class, we are going to look at sequence. So till we see in the next class, bye-bye.